Swayam Prabha. Digital India. Educated India.
Hi friends, now we will discuss on the topic hydro energy. Hydro means water. So, hydro energy is the energy which is generated from the water. So, in case of wind energy, we have discussed that the flow of air has some kinetic energy and that can be converted to electrical energy by using turbine and generator. So, here also when the water will be in flow, then the kinetic energy of that flowing water can be converted to mechanical energy in turbine, which is followed by conversion in electrical energy in the generator. So, in this case we need the flow of water, and this can be ensured by making dam or by using some river flow or canal flow, etc. So, now in this class we will discuss on hydrologic cycle as a renewable energy source, then mechanism of hydro energy production, components of hydro power plants and their role, classification of hydropower and hydropower schemes, advantages and disadvantages of hydropower and hydropower in India and world. As we discussed that flow of water is required for hydro energy production and availability of water is also necessary for it, and this is gifted by nature. So, in terms of hydrologic cycle, you see here the water which is evaporated from the ocean, it is converted to cloud and again precipitates. We know it very well that the water cycle, and then when it precipitates on the land or in the water, then from the land the water is flooded and it comes to the river stream. In the mountain it comes to the dam and dam to river stream, and the water gets velocity in this river and in this dam. So, the velocity of the water will be used to rotate a turbine, in fact the kinetic energy of this flowing water will be used to rotate a turbine blade, a turbine rotor, and that will be connected to a generator for electricity production. So, you see this figure shows us that for the production of electricity, hydroelectricity, we need the flow of water that can be done by dams, that can be river flow, water flow or tidal barrage or water wave power. So, these different sources which can be used to ensure the velocity of the water or the flow of the water, and that the water flow will come to the water turbine, and then turbine rotor will be there and blades will be attached to this rotor and it will be rotating, and the shaft will get some circular movement here which is coupled with the generator, and then AC power will get, and the water which is coming to the turbine that will lose its velocity and it will go to, or in terms of the kinetic energy, the kinetic energy will be lost here of this water stream and that will go as tail race. This is the mechanism of hydro energy. And now the hydro, what will be the power we can achieve through this hydro turbine, that will depend upon some factors, that what is the flow of it, what is the difference in the head from dam to turbine, or so that we have to determine, and the power determination is can be done by using this formula, that power in watt, that is equal to rho g q h into efficiency of the system, the overall efficiency including turbine, gearbox and generator. And H is here head, water head in meters, Q is discharge in meter cube per second, and rho is the density of water in kg per meter cube. Now, if we know the, as you know, the density of water is equal to 100 kg per meter cube, and if we use this 100 kg per meter cube for water, then this watt in terms of kilowatt will be converted to 9.81, which is for G, and Q into H into efficiency, and this 1000 here. So, that will be converted in kilowatt. So, in kilowatt 9.81 into efficiency into Q into H, that is the formula which can be used to determine the power productions in the hydropower plant if we know the head and if we know the flow. Then annual production can be calculated by the formula, that power into the time. So, what is the power we have? 9.81 into efficiency into Q into H, and then we have to, we can multiply it with the time. If it is time, it is in hour, then that will be in kilowatt hour. So, that unit of electricity can be produced from the thermal power plant, and we can calculate in any hydropower plant what will be the energy generated in a year or during any span of time. Now, we will see one problem statement. Say a mountain stream flows over a terrain where micro hydropower plant is possible, where an effective head of 50 meter be built and a flow rate of 0.6 meter cube per second can be maintained. How much power can the hydro plant generate? So, this is the question. So, assume plant efficiency is 83%. So, in this case we have the formula, that is equal to P equal to 9.81 into eta efficiency into Q into H. Here H is given, that is equal to 50 meter, Q is given, that is equal to 0.6 meter cube per second, and efficiency is given 0.83. So, we can calculate the value of P in kilowatt hour, that is equal to 9.81 into 0.83 into 0.6 into 50. So, it is coming 244 kilowatt. So, in terms of megawatt, that will be 0.244 megawatt. So, then how much energy will be produced in each year? That will be, say, this power 0.244 megawatt into 24 hours per day into 365 days per year. So, that will be the total 2137 megawatt. Then if we want to know what is the number of population that can be supported by this energy, then that can also be calculated if we know the consumption of energy per capita. So, assuming per capita electricity consumption in India as 780 kilowatt hour annually, then the number of populations that can be served by this energy is this, how much energy we are producing divided by 780 kilowatt hour, then we are getting this much equal to 2740 people. So, this much of people can be served by this hydropower plant. Now, we will see the components of hydropower plant and their role. So, this figure shows us schematically one thermal power plant. So, here we see some civil structures are there. These are the civil structures, and this is our reservoir, water is stored here, and then water is passed through this penstock to this turbine, and then turbine casing etc. is there, and then generator, electricity is produced. So, basically if we classify these different parts of it, so one is civil work, that is civil works, control of water flow, the main role of this. Then here the kinetic energy of water is converted to mechanical energy. Here the turbine shaft will be rotating, will give some rotatory movement, and that is done by the flow of water. So, that hydromechanical equipment is important as the heart of this whole plant, and then conversion of kinetic energy of water stream to mechanical energy, that is the main role of this part. And then third is electrical equipment. So, this mechanical energy in the shaft will be converted to electrical, and then for distribution etc. we need some dedicated system. So, then conversion of mechanical to electrical energy it is done by electrical equipment and power. So, that is the different parts of it. Now, we will see the civil work contains dam or intake or diversion in some cases, we will discuss and we will see some figure which will explain these things, and then power channel, and then desilting tank for removing the silts, and 4-bay tank to take care of small variations in flow. So, during the time a variation in the flow, so 4-bay water will be stored and it will maintain the continuous flow of the water, and then penstock through which the water will come to the turbine, and then surge tank or chamber in case of dam it is available, powerhouse building. So, one building is also required, and the tail race, that is exit from the powerhouse. So, these are the civil work we need. Then hydromechanical equipment, we need turbine, we need gate, we need valve, and we need speed increaser. Electrical equipment and power evacuations include generator, transformer, controls and protections, and transmissions and distribution. It is going to grid or it is off grid, both options may be available. So, now we will see how the hydropower plants can be classified. So, that can be classified depending upon the capacity. So, pico, micro, mini, small, medium and large. So, pico means that is installed capacity less than 5 kilowatt, micro 5 kilowatt to 100 kilowatt, and mini 100 to 2000 kilowatt, and small 2 megawatt to 25 megawatt, medium 25 to 100 megawatt, and large greater than 100 megawatt. So, these are the typical range which is used for the classification, and then on the base of head also, that is your ultra low, low, medium and high head hydel power are classified. So, ultra below 3 meter, low 3 to 30 meter, medium 30 to 75 meter, and high 75 to and above. Somewhere in some reference it is given as 75 is given as 300 meter. So, classification of hydropower on other basis also, based on purpose, whether it is for single purpose only for electricity production, or it is have some other purpose also, like say Teddy dam, it is irrigation plus power generation plus drinking water, that way you can classify, and classification based on hydraulic features. So, what are the hydraulic features? That means conventional hydropower plants, that means only it is the dams or rivers are used to produce the electricity, or pumped storage plants, that means recycling of water for supplying peak load. So, from the bottom tank to water will be sent to the top tank. So, that way also it is possible, but normally it is not used in the country, and the tidal power plants is also another type of power plants. And then we may classify on the basis of operation, that is your isolated plant or grid connected plant. There may be the energy produced in the plant can be connected to the grid, or it may be used off grid for meeting the local need. That is hopefully hydroelectric power for Bombay only. Then we will see the schemes for hydropower. So, we have runoff river, we have canal based, we have storage dam, we have pump storage. So, runoff river we will see, in this case normal flow of river is not materially disturbed due to the construction of a plant. At first we see the figure, here the river is there. So, this river some diversion is there here. So, desilting tank for the silt separation, then it is coming to 4-bay. The main objective is to ensure the constant flow of water here through the penstock to the turbine, and then in the turbine the water is coming and electricity is generated, and this is your tail race, and again it is coming to the main river stream. So, this is with small diversion of water without affecting the main stream of the river, this hydel power plant can be established, and this is called runoff river power plant. And these are the some features, neither have a large reservoir nor do they have a diversions of the water away from the main channel, and powerhouse is located along the main course of the river and do not substantially alter the regime of the river, and small pools of reservoirs to provide the necessary pondage in order to balance day to day fluctuations, generally medium and high head installations, and then quite popular in Europe and hilly regions of India. So, these are some features of this runoff river. Then canal based plants are also available. So, here these are the mainstream here. So, here we are getting powerhouse. So, this is our powerhouse, water is coming through this is the diversion canal. So, this is your canal and this is diversion canal. So, this water is coming here, electricity is produced and again it is going and meeting there. This is one example of say canal fall based system, that is Ganga canal 10,500 cubic capacity, and then Pathri powerhouse 3 into 3 6.8 megawatt capacity, and Mohammadpur 3 into 3.1 megawatt. So, 3 units are there for 3.1 megawatt capacity. Then storage dam based hydropower scheme. So, this is also very important one and widely used, like say Tehri dam. So, storage dams, this is our dam here. So, water will come from this, there is a penstock and this is our powerhouse, and then water is going as a tail race, it is meeting the main stream of the water here. What we do, that dam is a dominant feature of this in case of storage dam based. So, dam is necessary and powerhouse is at the toe of the dam, and the no diversion of water away from the main river is involved. So, this is the basic features of this type of hydel power plant, like say Bhakra, Hoover and Tehri are of this type. So, here it is coming the penstock and it is turbine, just I have mentioned in this case this is one. So, this is the photograph of Tehri hydel project, that is generation capacity 1000 megawatt and then surface of impoundment 52 kilometer square and water storage 4 meter cube, irrigation potential 2,70,000 hectare and drinking water 1.2 into 10 to the power 6 meter cube per day. Then pump storage power plant, this power plant as you have mentioned that the water will be sent from lower head to upper head at the high elevation to ensure the flow of water when to meet the peak load, and in this case it is the indirect way of storing electrical energy, and two reservoirs with a high difference in water levels between the two is very essential, and these two reservoirs may be both the reservoirs on the same river, maybe on two different rivers, or higher reservoir and artificially constructed pool and lower reservoir on a natural river, that can be possible, or the lower reservoir is a natural lake while the higher reservoir is artificial. So, that way different types of option can be produced. Now, we will see the advantage and disadvantage of this power production, hydropower production. So, it has obviously more advantages because it does not create any pollution, emission free with virtually no carbon dioxide, no SOx and no NOx, and renewable resource with high conversion efficiency. The high conversion efficiency is very high in this case, it is greater than 80% efficiency, but whatever other thermal conversion methods we have discussed in case of combustions or gasification based or IGCC, all are having lower efficiency than this. And then dispatchable with storage capacity and usable for base load, peaking and pump storage applications, and scalable from 10 kilowatt to 20,000 megawatt, and low operating and maintenance cost and long lifetimes. These are the advantages of this system of this power plant, but it has some disadvantage also, like frequently involves impoundment of large amounts of water with loss of habitat due to land inundation, and variable output dependable on rainfall and snowfall. So, rainfall and snowfall affects the availability of water and disturbs the continuous flow of it, and impacts on river flows and aquatic ecology including fish migrations and oxygen depletion, and then social impacts of displacing indigenous people, that is also one major issue, and health impacts in developing countries, high initial capital cost and long lead time in constructions of large projects. So, these are the disadvantage of this hydel power plant, and that is many times we see the debate whether such and such states should go for hydel power or not. And these are some examples of world's largest dams and hydropower generation. So, you see hydropower is used in different countries like China, Brazil, Venezuela, United States, Russia, Canada and Romania, Serbia. Just some examples are given here. Out of these, the 3 judges, that is 2009 it is established, it is 18,200 megawatt, the largest capacity in the world. And in India we have many hydropower like say Bhakra, Dehar, Kalindi, stage 1 and Saravati and Koyana, Nagarjuna Sagar and Idukki stage 1 and Srisailam and Salal and Ranjit Sagar and Chamera 1, 2, 3. So, these are different projects and these are the rivers on which these power plants have been installed and these are our installed capacity. So, these are the overall discussion, some information on the hydel power plant, and we will discuss in the next class on different mechanical equipment and electrical equipments used for the production of electricity. Thank you very much for your patience.